on the Computer Chronicles, we take you to the Silicon Glen in Scotland. We'll go to Dundee, home of DMA, the guys who made Lemmings. You'll see a new screen phone, a telephone that acts like a PC. We'll see one of the fastest computers in the world trying to solve the problem of traffic congestion and pollution. And we'll take you to the labs where the green laser was developed out of a low-cost CD audio player. And to the Scottish Highlands for an innovative program which lets you see 16 different computers on one PC display. All this and more on this week's special edition of the Computer Chronicles.
Computer Chronicles is made possible in part by Hewlett-Packard Personal Computers, developing PCs for business. Additional funding provided by the Software Publishers Association, presenters of the Codies, the annual Excellence in Software Awards.
Think of a Scotsman, and this is the picture that comes to mind, a Highlander in kilts playing the bagpipes. But these days, that's mainly tradition, ceremony, and history. Today's Scotsman is just as likely to be wearing jeans, a t-shirt, and a baseball cap, and be running his own software company.
Over here you'll find a really fantastic blend of technical talent and creative talent, and that goes way back to the education system here. Specifically, we're turning out great programmers out of the universities like Edinburgh and Strathclyde, and also alongside that, fantastic artists from places like Duncan of Jordanson Art College in Dundee, Glasgow Art School and Edinburgh Art School.
Chris Vandercurl founded VIS Interactive Media here in Dundee, Scotland. VIS started out as a corporate multimedia company, but it is now moving ahead full steam as a dedicated games company. VIS was inspired by the huge success of its neighbor down the street, DMA Software, the creators of Lemmings, one of the most successful computer games of all time.
Well, essentially, I mean, that really gave us part of our impetus to know that we could do it. I mean, they pulled in a fantastic deal with BMG Interactive this year, and also with Nintendo last year. Obviously, they've got a great track record, but it proves that you can do it with Scotland. Sorry, you can do it from Scotland, you know, with the right blend of talents.
VIS is currently working on several new games, pushing the limits of interactive cinema and high-end gameplay. One of their strategies is to build artificial intelligence into game characters.
But the idea is to take your characters in the game and really give them essentially an AI personality, so that they can react to situations by a set of rules. You know, they live life by a set of rules like we all do, and it's how complex a set of rules we can get these guys in the games to react to. One of the things that's going to happen in there is when you're working on multiplayer internet games, it's going to be very difficult to tell whether the character's actually being controlled by somebody at the other side of the world, or they're actually, you know, running off an AI engine.
Why has the United Kingdom and Scotland in particular been so successful in developing hit games? Chris says it's due in part to the success of a great game platform in the UK, the Commodore Amiga.
Right across the road here was the factory where the Sinclair ZX Spectrum got built. And Dundee, it's one of the things why DMAs are there today, and really essentially while we're there, is these machines were coming hot off the press. We got involved in them really, really early. Then these guys migrated up to the Amiga, so by the time they were coming to university, they had practical experience of programming a preemptive multitasking operating system, you know, with ASIC, good ASIC graphics chips, you know, the whole works of what's now the basis of these really hot custom consoles. So essentially, yeah, it was tremendous grounding for the programmers that are now working on games today.
While Chris brings his young enthusiasm to the task of software design, Sir Hugh Smeaton, founder of Lindbergh Technology, brings decades of work as one of Scotland's most respected electrical engineers. Hugh is a man with a mission: to bring intelligent energy management to the home and to bring interactivity to the phone. This is a model of Lindbergh's innovative home energy management system. It uses existing power wiring to network the home, and it can do virtually everything from manage all the home's appliances and energy sources to providing a burglar alarm system. Lindbergh has also developed the software and firmware for the new Philips screen phone. This is an intelligent phone which brings internet-style functionality into your telephone. The phone has a PC-MCIA slot for added memory and software applications. It also has a smart card slot so that you can download credits to your card from the phone. You can monitor your utility bills with the screen phone. You can order groceries or wine. And you can even pull out the small keyboard to use it as a full-fledged internet terminal. Jobber Corporation is another example of Scottish engineering expertise. The company is actually based in San Diego, but they do their R&D work here in Livingston, Scotland. Jobber's specialty is noise cancellation technology, as used in consumer products like the Noise Buster, but also used to design improved microphones for future speech recognition applications. Jobber's noise cancellation technology reduces background noises and so makes it easier to use voice communications in an open office environment. Jobber is located in the Livingston Software Center, a government-sponsored technology park where startups can find some much-needed nurturing during their early, difficult period. In fact, the government of Scotland, through various agencies, is a major factor in the growth of the Silicon Glen area. The government is working hard to shed the old image of kilts, sheep, and bagpipes in favor of the new Scottish image of high technology. And Scotland is not alone in this effort.
Again, in terms of a new inward investment, the United Kingdom benefits us all. And there are cases where we have competed unsuccessfully and lost a big company, let's say to the north of England. Well, our answer to that is good luck to the north of England. But once that company is there, we'll be in trying to get business from it and supply it from Scotland.
Scotland and Ireland are fierce competitors for American technology investment dollars. They each have scored major victories. Apple and Intel have large installations in Ireland, but the Scots say Ireland lures companies with big tax breaks. That is not the Scottish approach.
I mean, there's got to be a balancing of what we're prepared to pay for it and what the benefits are. And we're confident enough about the infrastructure and the skills and all the other benefits that Scotland has that we're not seriously concerned about that.
One of Scotland's successes has been the investment made here by Hewlett-Packard. But one of the Silicon Glen's most aggressive new local startups is taking aim at HP and their network management business.
It's all about processing power, and in competitive situations where we've been tested, our processing power has been proved to be leading edge. It's all about the ability to handle all the data coming at it. We're the number one at that. What we aren't is we're not number one in sales. That's dominated by the large corporates, such as Hewlett-Packard, but we aim to challenge them in the years to come.
Wilson's company, Solcom, makes a network management system called Land Rover. Solcom claims its product is superior because it is a hardware-software combination that moves most of the network management and analysis overhead to the Land Rover hardware, thus not slowing down the network itself. Land Rover also monitors routine network activity in a proactive way and alerts the network manager to possible problems before they occur.
There's no reason why we can't challenge America's in our same language barriers. There's no language problems. We have a huge market here that we can tackle. There's absolutely no reason why a European company can't take on the Americans in the global networking market.
Solcom is a tiny company compared to large corporate competitors like HP and Cisco, but they feel this gives them an advantage.
We're light on our feet. This market is all about being able to be light on your feet, seeing a niche, going for it. For a corporate to respond to the continual changing, it's impossible. Their mechanisms aren't there. Small companies and companies that are only light on their feet in terms of development are the only way that it can be done, and that's what we bring that the corporates can't.
Object Software Technology is another Scottish software startup. OST was able to develop an innovative object-oriented programming debugger that offers developers the first real-time object debugging tool. OST thinks it was able to succeed because it wasn't part of the existing software establishment.
We, in some ways, started from a fresh start. We were immersed in objects from an early stage, and we'd always thought about objects and how they communicated, how they related to one another, whereas I think a lot of the tool companies that are about just now have got a legacy of procedural debugging tools, procedural debugging technology.
And you know, it's hard to take that and shift it and move it to a completely different perspective, a completely different way of viewing systems. And so I think our fresh start was a big advantage.
OST's product is called Look, and it graphically displays what a C++ program is actually doing in runtime. This is a great tool for debugging and for understanding code that comes from other members of a software development team.
Look graphically displays to developers what their programs are doing at runtime. Most development tools that are available don't take advantage of the structure that's inherent in C++ and object programs. Look takes advantage of that structure to display at runtime the objects in their application, how the objects communicate, how the objects are related to one another, and all that information is key for trying to understand the structure of the application, for trying to find bugs, for trying to understand other team members' code. And so it's those graphical views, those higher level views of the application that Look presents to developers.
OST was facing some major global competitors in the programming tools market and some biases against a local Scottish company, but they overcame that.
Even selling into Europe, most European customers tend to expect software tools to come from the States, and so in some ways there are two problems. But in our area, the key thing is having a tool that works and is productive and helps developers. And if you have a product that really helps the software development process, developers tend to not worry too much about where it came from.
In the Silicon Valley area, there's UC Berkeley and Stanford. Along Route 128 in Boston, you've got MIT and Harvard. It's basically the same story anywhere. If you're going to build a high-tech industry, you need proximity to great universities. And here in Scotland, there are plenty of them.
We're looking for a place where there is a plethora of, if you like, brainware. And it happens to be that in Scotland, the university does, in fact, produce people with a very high caliber, people that are very suitable for a dynamic industry like software industry.
Adobe has its European headquarters in Scotland. Adobe is the fourth largest software company in the world, after Microsoft, Lotus, and Novell. It set up shop in Scotland because of its belief that Europe is in some ways a more important software market for Adobe than the United States.
Europe is important not just to Adobe. It should be important to every US software company because Europe indeed is the largest software trading bloc at the moment. The reason for that is Europe has about 370 million people. That's Western Europe alone. If you add to that the emerging Eastern European market, which is another 400 million people, the GDP of Europe is 10% more than, that's Western Europe, however, than the US. It becomes a very attractive market.
Adobe runs all its European service and support out of Scotland, and it is taking advantage of Scottish expertise in artificial intelligence to do some software AI work here for future Adobe products. Perhaps the most well-known source of computer science talent in Scotland is Edinburgh University. After Oxford and Cambridge, Edinburgh is the third highest ranked university in the United Kingdom. It is famous for its work in optics, speech, human-machine interface, artificial intelligence, and parallel processing.
The university has a very broad range of IT or computing activities, ranging right from the design of chips right through to very high-end artificial intelligence applications. And there are about 12 or 15 units within the university, all of which have world-class reputations in their particular subfields.
In fact, the fastest computer in Europe and the third fastest computer in the world is this Cray T3D at the University of Edinburgh's Parallel Computing Center. The T3D uses Digital Equipment's alpha microprocessors, which are also made here in Scotland. The Cray supercomputer has 16,384 processors, a maximum theoretical speed of 50 gigaflops, and 212 gigabytes of memory. Its mass storage is in the terabytes, and it uses this robotic storage device from IBM. The computer uses a 200 kilowatt power supply running at 400 hertz, and it has to be liquid cooled. With over 16,000 microprocessors, the software challenge is to figure out how to get all this computing power to communicate and coordinate.
In order to put software onto parallel machines, you have to divide the responsibility for different parts of the work across processors. And in doing that, you introduce overheads of synchronization and coordination between the processors. And that skill in converting software from a traditional form into a form suitable for execution on parallel machines is where our core skills lie.
In fact, researchers at the University of Edinburgh have developed the standard for passing messages among CPUs in a parallel processing supercomputer. It's called MPI, Message Protocol Interface. This code-sharing standard is now being used at supercomputer centers around the world, including those in California, Los Alamos, Carnegie Mellon, Ohio, and Minnesota. What the computer scientists at Edinburgh University are doing with their supercomputer is also leading edge. They are using their immense processing power to solve a major global problem: traffic congestion and pollution.
Traditionally, traffic modeling has been done by modeling cars on roads like water flowing down through a pipe. Now, the problem with that is that you can't adequately describe what happens when traffic jams or congestion build up and break up once the jam has cleared. Now, of course, those are exactly the circumstances you're interested in when you're modeling traffic, because you want to understand how to design your road network to minimize congestion. You want to understand where pollution is going to happen.
The university is now marketing its traffic analysis software around the world. The traffic management system was a finalist this year for the Smithsonian Award for Outstanding New Software Technology. The artificial intelligence work at Edinburgh University has been so successful that the department has now spun off a separate company called the Artificial Intelligence Applications Institute. AI markets its expertise and products to such companies as IBM and Unilever. The institute is working in three main areas: planning and scheduling, decision support, and knowledge engineering. The U.S. military used the Institute's planning and scheduling systems to manage troops and supplies during the Gulf War. The university is one of the few non-domestic vendors doing business with the Pentagon. Another area of expertise for the Artificial Intelligence Institute is something called constraint programming, determining how to solve problems within the real-world constraints of production capacity, union rules, etc. This is an example of a program being developed for a mining company which has to deliver chemicals to road repair sites. A mundane-sounding problem, but with extraordinary complexities for efficient planning and scheduling. The other leading computer research center in Scotland sits just a stone's throw away from one of Scotland's most famous landmarks, the St Andrews Golf Course, home of the British Open. This is St Andrews University, a world leader in optoelectronics and laser engineering. The microchip laser group here has developed the world's smallest, lowest cost, and most efficient green laser. They did it using a common inexpensive red laser beam from an ordinary CD audio player.
We've now produced something that's very, very much smaller, very much more long-lived, and whose unit production cost will fall drastically as numbers are produced. So it's the manufacturing process now is very much easier. The package is very much smaller, lower cost, higher efficiency, much higher efficiency, and altogether a much more usable product.
The scientists here turned a low-class red laser into a scientifically useful green laser by developing this minute crystal and lens combination that produces an intense, small wavelength laser beam. The shorter wavelength green laser is used in critical applications such as circuit board inspection, biomedical cell marking, and drug research.
The shorter the wavelength, so the further into the green and blue you can get, the smaller the spot you can focus that laser to, so the smaller the object you can see. And also the microchip laser gives a laser beam that is very, very much better in terms of spatial quality than that comes out of the diode laser directly itself.
The next step for the laser group at St Andrews University is to figure out how to harness the power of their laser technology to develop the world's first optical computer. There are significant advantages to moving signals inside a computer with photons rather than electrons.
In terms of moving the data, then potentially much lower time delay in between boards, much lower crosstalk potentially, and in many ways it's very much easier to get high-speed signals in optics than it is in electronics. You haven't got the capacitance there to worry about, and things travel down optical fibres with remarkably little dispersion. So you can put a short pulse in one end, you get a short pulse out the other end. You can put your timing pulses from one centre point all around your computer very rapidly with very little time delay to the different components.
As you would expect, St. Andrews University also has a leading mathematics department, where they are using computers to improve the way they teach math. This is a program developed here called Math MacTutor. It is innovative in that it doesn't really try to teach anything. Rather, it is a mathematics laboratory in which the students can discover basic principles and rules on their own. This is an example of the geometry part of the curriculum in which students can discover the rules of symmetry. These are the headquarters of QData Information Systems, one of the most unusual software companies you will ever find. Their office is in a converted stables in a remote village of the Scottish Highlands called Eventon, somewhere north of Loch Ness. Here, in the middle of nowhere, Ian Clark has done something no other software company could figure out how to do. He has created a software program called MARC, an acronym for Multiple Access Remote Control, that lets you view the activity of up to 16 different computers on one computer display.
We were very surprised to discover that we were the first in the world to actually create this. I mean, it took us 4 years. We were expecting at any time that one of the big companies that were already into the remote control software would have basically come up with a product that would do something similar. But no, we were the first there and still remain the first.
The MARC software allows up to 16 users to work together, seeing the same screen at the same time, or it allows a group leader to see the work of all 16 participants on one master screen. The software is interconnection independent, meaning some members of the group can be on ordinary modems, others on ISDN, and others connected via a Novell network or through the internet. The technology has applications for network management, allowing a network administrator to actually look at what is on the screen of 16 different clients. And there are tremendous educational and training applications too. This is the remote Dingwall police station in the Scottish Highlands. It's headquarters for a police territory that covers 1/6 of the entire landmass of the United Kingdom. Distances within this district are immense. Yet using MARC, a computer trainer can work with students at 16 different locations scattered over hundreds of miles and actually monitor their work by looking at one computer display. Ian Clark lives an idyllic life here in the Scottish Highlands, all the while trying to compete in the gritty world of the global software market. He says he hopes that what he is doing will help change some people's minds about what really goes on in Scotland.
I think sometimes they tend to just see it as a place of dramatic landscapes and hills and castles and lochs and the occasional monsters in a loch. But in reality, there are a lot of very innovative businesses that are very successful that are operating here. I think that living here actually provides a different dimension to one's life, and I travel a great deal on business and the company's business, and when I come back here, this is the most peaceful setting, and I think in business it's important to be able to have that period where you can relax and unwind and throw off some of the frustrations of trying to sell a brilliant product into a worldwide global software market.
For the Computer Chronicles, I'm Stuart Chaffee in Scotland.
Computer Chronicles is made possible in part by Hewlett-Packard Personal Computers, developing PCs for business. Additional funding provided by the Software Publishers Association, presenters of the Codies, the annual Excellence in Software Awards. Videotape copies of all Computer Chronicle shows are available for $32.50. Please order by show number and topic. And for more detailed information about the series, guests, and products featured, you can also order a subscription to the Chaffee Letter. In each issue, Stuart provides his unique insights and thoughts about the fast-changing world of personal technology. Videotapes and the Chaffee Letter can be ordered by calling 1-800-800-9520 or by writing us at the Computer Chronicles.
you own a computer? Thinking about buying one? Trying to figure out what software to get? Trying to cope with PC problems? Want to decipher the internet? Don't make an expensive mistake. Watch Computer Chronicles each week for up-to-date advice on the latest in personal technology, computer hardware and software, and a guide to cyberspace. There is help out there every week on the Computer Chronicles.